Let us today understand how to find the maximum or minimum number from a given set of numbers using microcontroller programming, 8051 programming, using the assembly code. So before going to the code, we'll do and run the code in KEIL New Vision version 5. Before going to that, let's understand first what is the algorithm behind selecting or choosing the finding the maximum number from a set of given numbers. Suppose this is a set of given numbers. These are decimal number. We will work with the equivalent hexadecimal for this in the program that we will see next. So these are the numbers. Suppose 18, 2, 26, 15 and 16, and we want to find the maximum number. Which one is the maximum? So what is the algorithm? What are the steps? How we do it normally? So algorithmic step will be that we will be needing two variables. In this case, for 8051, we will use two register. One is accumulator A and B. So for first, what we will do, we will assign this very first number in the series to our accumulator register. So now A contain the first number 18. Now what we will do, now we will start a loop from the second number onward to the end, last number. If there are n numbers, then the loop will run from 2 to n minus 1. So if there are 5 numbers, then the loop will start from the fourth number and it will go up to decreasing one by one, 4, then 3, then 2, then 1 until 1. This is how loop will go. This by decrementing the counter, that is the number of elements. So that we will see in the program. Now what we will do next, we will assign the very next number, that is here in this case this is 2, to the B register. Okay, now what we will do, we will compare A and B. So the comparison will be something like if A greater than B or A less than B. This we will check. So if we are finding the maximum number, then our check will be like if A greater than B, that is among A and B, among first two numbers, if A is already the maximum number, then do nothing. If A greater than B, do nothing. That is, we can say skip doing anything, skip. Else what we need to do, else what is the highest number? If it is 18, suppose this is 19. In that case, we always want to have the maximum number in register A. In that case, what we need to do, we need to store the maximum number in A. So if A is less than B, that is among A and B, B is the highest number, so we need to store the value of B in A. In that case, we will write A equal to B. If A is equal to B. So in terms of microcontroller programming, this will be like move A comma B, that is put the value of B in A. So this is the basically logic. Then we go to the next number 26. Then again, now till now among these first two, the highest number is 18. A contains 18. Now when we check this 18 and 26, now 26 is more, so the second case will come, A is not greater than B, so in that case we need to store this 26 into A. So in that case the value of A will becomes 26 after the third iteration, that is the iteration with the 26. Now again we go to next number 15. So 15 is assigned to B, and then A have 26, B has 15, so A is greater than B, do nothing. Now next go, now B will be assigned to 16, so B contains 16, A contains 26. Again A is greater than B, do nothing. Then we see that our counter ends 4, 3, 2, 1, 0, so no more elements. So now A contains 26, that is the highest number. If we need to find the minimum number, in that case what we need to do, just simply the logic will be opposite. Instead of this one, we will write here A less than B. If A less than B, that is A is smaller than B, then do nothing, that is skip, and else put the lower value in A, like else keep A is equal to B, that is move A comma B. Simple. In this way, if we go when A is 18, so we are telling that minimum number is 18. Then when we are comparing 18 and 2, then we see that A is less than B, so A should be equal to B, so A's value becomes 2. Now B goes to third number 26. In that case again we check, A has 2, B has 26, so A is less than B, so do nothing, skip. Again then 15, A has 2, B has 15, so do nothing. Then B will be going to 16, again A has 2, B has 16, so do nothing. So the minimum number is stored in A, that is 2. So this is the logic, this is the algorithm. So this we need to implement in our program. Let's see how we can do it. So we'll first write how we can find the maximum number, like then simple we can just changing one word, one command, this JC and JNC, we can do largest or minimum both. So what we have first done, we have first stored the 5 numbers that we want to use. There is the series of input number that is stored from 30H to 34H, 30H, 12. This is the numbers we are storing. Then what we are doing, we told that we need register A and B, accumulator and B, for the program execution, and one we need the counter, that is how many number of elements are there, that we are using R1 register. There are 5 elements, so we are moving move R1 comma 5, that is we are storing 5 in R1, that will be we will use during the loop condition. And we are doing move R0 comma has 38, that is in the R0 we are taking the first address, that is the first element. Now what we are doing, move A comma at the rate R0, that is the content of R0, memory location pointed by R0, memory location pointed by R0 is 38, the content there is 12 hexadecimal. This 12 hexadecimal value is now stored in accumulator. So let's run and see. So that will be good for us, because that will save us time. So we'll target, this is done. Okay, now go to debug. Now this is debug window. Now as we were line by line executing, for first 5 lines executed, so these are the input value already stored. Now what we are doing, now we are moving our the first value into A. R1 has 5, so R0 now R0 contains 30H, the first address for the data. R1 has 5, we see 5, R0 has 30. Now accumulator will be loaded with the first number, that is 12. Let's execute that line. Now executed, accumulator has 12, first number, this is 12H, this number. Next what we are doing, decrease R1 contains 5, now one element is processed, so R1 will be 4, so one element process, R1 becomes 4. Now increment R0 we need to increment, because R0 is 30H, 12. Now we next time we need to get the next item, that is 02, so we have to, that is present at 31H, so we have to increment R0. So we increment R0 becomes 31. Now we are inside the loop. What we will do in the loop, we move the second element now pointed by R0 to B register. So now B register contain the second value, that is B register contain the 2. Now what we will do, increment R0. Now R0 should point to the third element, R0 becomes the third element, R0 now becomes 32 memory address, that is this will be point to 1A. Now what we do the check here. CJNE A comma B comma check. What does it do? This is basically compares A and B and check if they are equal or not. If not equal, go to check. So if A and B are not equal, go to check. If equal, then don't go to check, rather go to next line. SJMP skip. So it will come to skip if they are equal, but in our case they are not equal. So what will go? They will come to check. Like they do not execute this line, it will directly go from this point to this point. That is this instruction JNC skip. So if we execute the next line, directly it will go to check, because A and B are not same. A is 12 and B is 02. So A is greater than B. So now what this will do, JNC, jump on not carry. If there is no carry, then it will go to skip. If there is a carry, then execute the next line. So when we this CJNE, what it does, A minus B. Now A has the value 12, B has the value 2. So if we do A minus B, that will become 10. That is A. So there will be no carry. So we can see that there is no carry. Carry is 0, auxiliary carry is 0. So this JNC no carry to skip. So it will move to skip. So it will come to this point. Alright, this point. Now what here we are doing? So we are trying to find the largest number. So A already has largest number among A and B, 12 and 2. 12 is the largest number. So A already contain largest number. So it is coming to skip, do nothing. Now we need to check the next number. So how we will get to the next number? We need to do this one, DJNJ R1 loop. What it does, it first reduces, decrement the R1 value. So R1 contains 4 because R1 has initially 5. Then we decrement 1 because first element is put into A register. Then we consider the second element. Now second element processing is done because 02 processing is done. Now we need to consider the third element, 1A. So we need to decrement R1 by 1. So it will decrement R1 by 1. Then after decrement, R1 value is 3, so it is not 0, non-zero. If non-zero, then go to loop. So as R1 is 3, we execute this line. R1 is 3, we see R1 value is 3, so it will go to loop. Loop means here. Now it will load again in the B register the next value. So what we are doing, actually B is done. This B is equal to 2 is done. Now B is pointing to this 1A, that is 26. So this is done here. Now B will load next R0 value, that is 1A. Now if we go to next, then B will contain 1A value. We can see 1A here. Now again we need to increment R0 by 1 because next time we will be needing the next number. So we increment R0. Now again the test if they A and B are equal or not. We see they are not equal, so it will go to check. So not equal, coming to check. Now A minus B, this CJNE operation does A minus B, as A contains 12 and B contains 1A. So 1A is more than 12. So this is actually A is less than B. So in this case we see there is a carry due to this operation. So in this case we need to check JNC, if jump on no carry, skip, it will not go to skip because there is a carry. So it will go to next line, that is move A comma B. So if we consider this, so move A comma B, because A contains 12 and B contains 1A, we see 1A is more than 12, so we are trying to find the maximum number. So A should always contain maximum number, so we should assign this 1A to A. This is done by this line. So move A comma B. Now A contains 1A because that is the highest number among the first 3, 12, 2 and 1. Now again we are going to DJNZ R1, that is R1 3 2. Now R1 will become 2. Again we go to next number and check. Now next number, what is the next number? We need to first execute, then you can see we have executed. Now A contains 1A and B contains the next number, that is 0F, this 0F. Now 1A is more than 0F, so it will go to skip. Sorry, it will go to check because there in the check there will be no carry, so it will go to skip. because no carry is 0, you see. So it will go to skip. Now again R1 will decrease. Now R1 has 2, it will become 1. So R1 now, if you see, R1 has become 1. That is the last element is processed. This is 1 0. This time B will contain 1 0 after this line. So B register contains 1 0, the last number. Then R0, these are already done. Then again check A and B. Compare. A contains the 1A and B contains 1 0. So 1A is greater than 1 0. So nothing to do. It comes to check. Then JNC skip because no carry. We see no carry. So JNC skip. And the skip, we reduce the R1 value, R1 becomes 0. As soon as R1 becomes 0, this will not go to loop because jump on non-zero. If R1 value is non-zero, then only it will jump to loop. Now R1 will become 0 because 1 to 0. So it will